All right, so a 2 by 3 within subjects design ANOVA. If you look here, we only have 3 participants and they each give us 6 data points. 2 by 3 is 6. Each participant gives me 6 data points. Um, let's go ahead and copy our data over into the output here. We'll copy it here and we'll get rid of the extra column that I made. No problem. Alrighty. I'm making sure all these are continuous. It got thrown off because of my last little outing there. But we have 3 participants with six data points each. 2 by 3 design. This is gonna be some fun. All right, I'm gonna pull the Jamovi up first. We want to analyze this ANOVA, repeated measures ANOVA. We're gonna hide things. All right. So first thing I do is I have to define factor 1, which is meditation. Yes. No. And then coffee, which has 3 levels of ten, 5, and 1. Now I put them in these orders because this is in line with my prediction. If you don't do this, you're going to have negatives all over the place, and you're going to have to really think about your data a little bit harder. But actually, it really doesn't matter that now that I think about it. But still, just be consistent. So, did they meditate? Yes. 10 cups of coffee. Meditate 5 cups of coffee. Meditate 1 cup. No meditation 10. No meditation 5. No meditation 1. All I'm doing is making sure everything's in its right place on my partial eta squared. And so now we got like the general ANOVA. We can see we have significant main effect of meditation, significant main effect of coffee, significant meditation by coffee interaction. So that is all good and well. What do we do next, right? Well, okay, let's deal with it like we do. The 2-level main effect, that's meditation. Let's sort of start there. I want to just see what it looks like. We know what the data are going to look like, but we still should do best practices here. You go, this meditation has more happiness than no. That's nice. That's going to be the headline. Meditation improves happiness. Which mean is larger? Meditation, which means meditation improves happiness. Is a significant mean difference? Yes, it is. Now, I'm calling it a mean difference because you're only testing the difference between 2 means. Even though it's an F statistic, it's still a mean difference. What is your best estimate of the population mean difference? Let's say 90% CI. Well, let's go ahead and get that. All right, so I'm here, and I'm going to go back. I'm going to make this a little bit bigger so we can see. I'm going to go back one more time. All right, so now we're at the 90% confidence interval of eta squared within subjects. I need to use that one because this is a within subjects factor. So let's just go ahead and pull out our F statistic of 19.692. 19.692. I should have made it a little bit easier for me to see. Now I got it. There are 1 and 2 degrees of freedom. Perfect. When I hit the run command, this is my lower and upper limits. So I'm going to go back to my packet. Go ahead and paste it in because I'm, don't want to forget this, but that is 0.015 is a small effect because 0.015 0, 1 is a small effect to a large effect. All right. I'm going to leave that there for later. Write your statistical sentence for this main effect. No problem. Let's pull it up. F with 1 and 2 degrees of freedom equals 19.69 P equals 0.047 partial eta squared, and I'll adjust the italics and all that stuff in a second, equals 0.91 with a 90% confidence interval between 0.016, which is 0.02, and 0.94. We don't put a 0 in front of there because the largest value it can take is 1. Boom. Get the italics in there. Ready? Perfect. Headline for this main effect: meditation improves happiness. I'm not gonna have you go get the Cohen's D and all that. It's just harder. I'm doing this is good enough. It's a little different than the between subjects. You just gotta trust me. We got a confidence interval. It's the best one we got. That's the answer I want. Okay. In the future, if you go to grad school, you should look up how to take these and turn these into 90% or 95% confidence intervals of Cohen's D, but it's actually kind of super complicated. And there's disagreement on if we should even do it, so that's a whole nother thing. So now my 3-level main effect, we want to do something similar. I just want to list my means from smallest to largest, I think. Smallest to largest. Smallest happiness is 1 cup. Next is 5 cups, and next is 10. So we got 1 is less than 5 is less than 10, and I don't mean that 1 cup is less than 5. 5 cups is less than 10, and 10 cups is greater than everything else. All right. Put that in the wrong area. Get rid of that. Perfect. Is this a significant ANOVA? Yes, it is. What's your best population estimate in words for the ANOVA effect? Well, we haven't done it. We did not get lucky where it was the exact same as before, but we will for the interaction, so that'll be great. So I have to go ahead and with 2 and 4 degrees of freedom, 2 for the coffee effect, 4 for the error effect. All right. My F statistic is 19 exactly. And I run the command. That is between a large and a large effect. So, large and large. I'm going to go ahead and just copy this one since it's right there for me. Write my statistical sentence, so I'll adjust this as needed. Paste. All right, F with 2 and 4. For this coffee main effect, 2 and 4 degrees of freedom. F with 2, 4 degrees of freedom equals 19 exactly. The p-value equals 0.009. What a p-value. Partial eta squared equals 0.91, which is nice. And then this, I meant to copy that over. I didn't, but it's just right there. 0.35, 0.93. 0.35 to 0.93. So that's nice. We've answered those questions so far. Run the post hoc test for this main effect and complete the table using 2 keys. So the one thing you're going to notice, I am not going to ask you to go out and get a 95% confidence interval for these specific effects. It's just a little too much work. You know we should. I'm not a huge post hoc fan anyways, so that's kind of why I'm doing it. But it's like name of condition 1 is going to be 10 versus 5. 10 cups versus 5 cups. My T statistic is 3.46. And my p-value is 0.13. When I look at 10 versus 1, which is the next comparison, 10 cups versus 1 cup, the T statistic is 5.00, and my p-value is 0.07. And finally, 5 versus 1, 5 cup versus 1 cup, the t-score is 4.00, and the p-value is 0.10. Now you're like, oh, nothing significant. You did something wrong, Dr. D. I actually didn't. This happens all the time with ANOVA. So you have a significant omnibus effect, but you're not finding specific differences between the different groups. When this happens, it's okay. You will reason it out. I'll give you the headline for this main effect in a second, but it's like essentially it appears that drinking more coffee may lead to more happiness, but we would need to run a better study to figure this out for certain. Whenever data don't match what you expect, right? This is a significant main effect that is, a large to large main effect, but we don't know which means are different from each other. That's okay. It happens. I'm not super worried about it. You would just say, well, based on logic, it appears that drinking 10 cups is better than 1. That was almost significant, even though it's not, so we can't say that. But that's essentially how it works. That just happens sometimes, and that's what you would say here. I'd accept a lot of things for this if this happens to you on the test, so don't worry. But what I really care about is that you're processing the data. Yeah, this sucks. This isn't great, but it just is what it kind of is here, right? Also, this happens a lot with follow-ups in ANOVA. Just does. We also ran a really small study with 3 participants, right? Just to sort of keep that theme going. Just we're learning how to process the data. Now our interaction. Let's go ahead and start where I always start, or should always start, even though sometimes I didn't in this video set. I want to go ahead and see my slopes. For the 2x3s, I always want to see the 3 slopes. This is the same slope pattern we talked about it before. For people that drink 10 cups of coffee, it appears that meditation does nothing for happiness. For those that drink 1 cup of coffee, it appears that meditation has a decent effect on happiness. And for those that drink 5 cups of coffee, it appears that meditation has a decent effect on happiness. You can see that, right? Describe each of the 3 lines first. So draw your interaction the 3 slopes way. This is the 3 slopes way. I'm not drawing it because I just copy and paste it. I should have said copy and paste, but you can draw it too. Describe each of your slopes. Perfect. I'll do it again. When people drink 10 cups of coffee, meditation appears to have no effect on happiness. When people drink 5 cups of coffee, meditation appears to... This one's 5. I know it's hard to tell. Yep, this one's 5. Meditation appears to increase happiness. When people drink 1 cup of coffee, meditation also appears to increase happiness. I just described my 3 slopes. I'm not writing them out. Is the ANOVA effect significant? That interaction effect is significant. Yes, it is. What is your best estimate of the ANOVA's population effect size? That's actually beautiful with this data. I would have to rerun the same thing I did before, but because all my numbers are the same for the interaction, you can see that here, right? I don't have to put 2 and 4 and my F of 19 into the program. I know I'm going to get the same exact answer, so I know that this is between a large and a large effect. The interaction is between a large and a large effect. So that is great. In fact, this whole statistical sentence is the same. So I'm just going to copy that for me right here. And that's not always the case. That just happened because this data was so pretty. And I made it up, right? I may have made it up wanting not to have to write so much in the answer sheet. But no, this won't always happen. Run your postdocs, but only look at the 3 tests that matter. For this one, I'm going to run it, but I'm not going to write out the whole table. I'm getting, we're probably getting a little tired of that. Well, let's see. I didn't even put the table in here. The 3 slopes that matter: 10 cup med versus 10 cup no med, right? We're not going to get a 95% confidence interval. You're noticing this right here. One of the issues with my data is that there were a lot in one of the conditions, there were no sort of mean differences there. You're seeing this right here. So when you see this mean difference is 0, your t is 0, your p-value is 1 for all of those. But those aren't the ones we need. We need 10 cup meditation versus 10 cup no meditation. So 10 cup meditation versus 10 cup no meditation. Mean difference is 0. Degrees of freedom 0. T is 0 and p-value is 1. Even though it's not there, that's hard. That's fine. That's what you would write. If you wrote NaN, the only reason that happened was because there wasn't that much variation in the data. Like it's not bad data. It's just that it was a little too perfect. That's what's going on here. So these 2 means are the same. T would be 0, P would be 1. That won't happen to you on the test. All right. T equals 0, P equals 1.00. Right, that's one of them. 5 cup with meditation versus 5 cup without. This is 5 cup with meditation. 5 cup with meditation versus 1 cup with meditation. 5 cup with meditation versus 10 cups without. 5 cup with meditation versus 5 cups without. That has a T of 3.46 and a P of 0.24. .24, that's non-significant. 3.46. P-value equals 0.24, that's non-significant. I'm not making you get the 95% confidence interval because these aren't necessarily for me. I'm happy with the interaction difference. I'm happy with you just saying the slopes, these 3 slopes are different in the ways they look in the picture. I'm fine with that. But I'm preparing you for questions other people might have you do, and because I'm doing that and I don't think it's that important, I'm just going to we're not going to get the 95% confidence intervals here. If you really care about that, you can look it up in how to do it. So yes, meditation with 1 cup of coffee, no meditation with 1 cup of coffee. Is that slope different? Well, this one is also not significantly different. T is 5 and P is 0.13, right? So we have an interesting case where it's like one cup med versus 1 cup no med. None of the T statistics were significant, but the slopes were different. The patterns of data were different based on the ANOVA result. Sometimes people want to know these comparisons, but that's actually not the best way to look at it. And now you're seeing why, because it doesn't make sense to break down a line slope in terms of 2 different t-tests and try to compare them. We know for a fact that there's some difference among those slopes. We can reason it out with our minds. No one's going to be super angry. but our t is 4.00 and our p equals 0.19. Okay. All right, I didn't ask for the, I didn't put it in here, but I meant to. What is my headline? Meditation improves happiness for people who drink less than 10 cups. That's my headline. And I literally just described the whole pattern, right? Like we described the 3 slopes before. I just blocked it down. I was like, look, meditation appears to improve happiness for those who drink 1 cup and those who drink 5, but not for those who drink 10. I just said it. That's it. So, like if you can summarize this in a sentence, do it. You can't always do that. You will always get your points correct if you just describe the 3 slopes, but sometimes you see a pattern. Now, question number 2 is the same as number 1, except your 5-cup condition was found to be incorrect and data are lost forever. Instead of rerunning everything, re-entering my data, I'm just going to go ahead and get rid of my 5-cup condition. I'm going to cross this one out. I'm going to call this one 1. And now I have to re-enter. I'm not going to restart from scratch, right? It's the same basic problem. Everything I did before about entering data matters. You don't have to take your data out of this one. But now I'm like, okay, I need to get yes, meditation with 10 cups. Happiness is the DV, meditation 10 cups. It's everything together. Happiness meditation 1 cup, 10 cup, 1 cup. So now I'm working on the next problem. We still got a little bit of that funky data stuff going on. I'll talk about it all right together. Let's look up here. We have a significant main effect of meditation, significant main effect of coffee, and significant interaction. What I love about this one is I can tell that all the data are the same. So that's great. Like you can see my F's are all the same, my P's are all the same, partial weighted squares are all the same. So that's going to make my life pretty easy. I'm going to write that statistical sentence once, but you'd write it 3 times in the paper. But when I get there, you can see that. Right now, I want to understand the main effect, not the interaction. So I'm going to go down here and I want to understand the main effect of meditation. So what do we see here? Meditation appears to improve happiness. This is the condition where everybody sort of shows the same. That's why we're getting those NAN results. Don't worry about it too much. But meditation appears to increase happiness relative to no meditation. That is a significant effect. All right. We don't need post-hocs for this. Let me get rid of those real quick. All right. I don't want those post-hocs making everything ugly. You know, my headline is that meditation improves happiness. My statistical sentence, it is significant. We can see all that. I think I've covered most of everything. My statistical sentence, let's go ahead and copy one from the previous problem just so I don't have to keep redoing this. All right. Meditation improves happiness. The statistical sentence is F with 1 and 2 degrees of freedom equals 25. F with 1 and 2 degrees of freedom equals 25. My p-value equals 0.038. My partial eta squared equals 0.93. Let's go to our friend here. This is a completely within subject's design as well. My F is 25 with 1 and 2 degrees of freedom. You can see that here. My F is 25 with 1 and 2 degrees of freedom. Run my command. It is between 8 and 95. So 0.08, 8%, and 95%. All right. So what does that mean for us? Well, we know that that is a medium effect because remember, it's 0.01% 0.06, 0.14. So that's between a medium effect and a large effect. Medium and large. There's no reason to run post-hoc tests because there are only two means being compared. We're not going to run post-hoc tests. We're not going to get our 95% confidence interval of Cohen's d. We also have coffee improves happiness, I believe. We'll give that a look here. All the data are the same, so that statistical sentence is going to be the same. So now I get rid of meditation. I put my coffee in there. And coffee improves happiness as well. It's the same exact F sort of result. So coffee improves happiness. That's my headline. I don't really have to say anything else. Everything's already been said, so I'm going to speed this up. And then finally, I want to go ahead and for the 2x2 interaction, I'm not going to run the post-hocs here. I'm going to run it my way. This is a significant effect where you can see when people drink 10 cups of coffee, meditation has no impact on happiness. But when people drink 1 cup, meditation improves happiness. Right? That's all that's going on there. There's the slopes. Those are the two slopes there. If somebody did ask you to do the t-test comparison, right? It's this one versus this one and this one versus this one. We might as well go ahead and do that. But let's write our headline. When people drink 10 cups, meditation does nothing for happiness. When people drink 1 cup, meditation improves happiness. That's sort of the take home there. The last thing that we would do would be getting our post-hoc test for the interaction, which we'd only care about the yes meditation 10 and no meditation 10. That mean difference is 0. That t is 1. That's non-significant. In fact, the other mean difference is non-significant as well. But honestly, there's only 2 slopes here. But if somebody asked your t is 5 and your p is 0.02, or your t is 0 and your p is 1, right? Like, you could fill out that table, but this happens a lot with ANOVA follow-up tests. That's why I hate ANOVA follow-up tests just in general, but also this data was just for a practice problem set. But now we have finished everything here. We have the same statistical sentence. This will probably never happen again. We just got super lucky, right? If I'm writing it, it's like, 1 and 2 degrees of freedom for the interaction. The F's 25, the P's 0.038, the partial rate squared is 0.93. If I enter it here, I'm going to get the same data. That's why I have the same output. But that's basically it. I would accept that. I would accept that for a 2x2. There's no real reason in a 2x2 to really do any follow-up tests. Just because other people ask it, I showed you how. For me, from now on, even on the test for any 2x2 interaction, you do not have to describe the follow-up post-hoc tests, but you will want them if it's a between subjects 2x2, because that'll give you, you won't want them for the interaction, but you'll want them for the main effect. So I will scratch that. Those are those 2 problems 2 and 3 on the within subjects packet. So this is within subjects factorial ANOVA finally done.